Well, thanks for the introduction. I'm Adrian, Cloud Research Engineer from i2cat, and I will explain you what we have done regarding the Vehicular V2X stack. So we have deployed a V2X stack in edge environments for improve the mobility safety. Okay, so well, first of all, I will give you a quick introduction of what is V2X and background and the V2X challenges. Secondly, I will show you the solution that we cooked, and then I will present two demos. The first one, how we use OSM to deploy the solution in edge environments, and a demo of such vehicular stack in a real environment in a pilot that we run in Barcelona. Okay, V2X background and challenges. So this is V2X technology. It's a communication technology that enables vehicles to exchange data with vehicles, other infrastructure, pedestrians, and networks. As you can see in the image, basically all the actors will be sending and receiving information. Of course, this should be in a real time, and this could help in the autonomous driving objective. Let's talk a bit about the standards. As you could imagine, different standards have been proposed from different regions, and being in Europe, the ETSI ITS standard. ITS stands for Intelligent Transport Systems, and well, basically the standard defines V2X technology, and you can see here at the right of the image the different layers. Basically, here we would have the access layers, here the network and transport. This V2X message layer is also called the facilitation layer, and here the application layer. And of course, it's really important here, the security. So which challenges do we have in V2X? We could imagine them: collision avoidance, traffic jams, roadworks, vulnerable road users. This is such an important one because as we are noticing these years with the rise of electrical scooters, this is an important use case to take care about these vulnerable road users. Intersection collision warning, and yes, we could imagine emergency vehicle warning. So which are the requirements of V2X? Wireless communication, for sure. We have on the one hand 11P, which is an enhanced version of Wi-Fi, cellular technologies such as 4G, 5G, DSRC, CV2X, and well, latency. Of course, V2X requires is a critical requirement. Ultra low latency, well, less than 100 milliseconds stands the standard. Security, accuracy, scalability, and interoperability are some other requirements. Regarding the infrastructure, as you could imagine, in order to tackle this problem, we need to onboard some antennas on the OBUs, on the vehicles. OBU stands for onboard units, and the antennas on the road and roadside are called roadside units. And for instance, this could be even lightweight antennas placed on post lamps, for instance. And well, the different vehicular communication types, we have V2I, vehicle to infrastructure, V2V, vehicle to vehicle, and the so-called vehicle to everything. So let me explain you our solution. What we have done is basically implement the stack, the transport, network, security, management, and access layers of the ETSI ITS stack. So we are able to create V2X messages. We have the CAM and the DEN messages, which are the standardized messages. For instance, the CAM messages are sort of a heartbeat message sent 100 times per second, and here under this message we consider speed, location, acceleration, the important things that we need in order to have a 3D vision of the vehicle. We have then messages which are decentralized messages, so maybe from the system we could send messages to the OBUs, to the vehicles, warning about an accident or whatever. We have tested our solution with different wireless technologies, with 11P, with PC5, with commercial 5G. Our solution includes sign and verify messages. Of course, the security is really important, as we could imagine, and it implements the geo-networking protocol, which is in the standard. Some more characteristics of our solution: ETSI ITS compliant. Of course, it's available for container-based scenarios, so we are like in Kubernetes, OpenShift, Helm, and therefore OSM. We are implementing an interface between the V2X world and let's call it the IT world, of course, as we are implementing this stack, we are abstracting all the vehicular intelligence. So an application could be developed in any language, in Python, in Java, and that could access to the V2X messages using MQTT. So from there, different applications could be built in order to, I don't know, a risk detector, collision avoidance, and more advanced cases such as autonomous driving. As previously mentioned, we are supporting 11P, LTPC5, and commercial 4G and 5G. And this is and should be a lightweight solution that has been tested in lightweight devices such as Raspberry Pis, Odroids, etc. Here we have the software architecture of our solution is built on Python, and as you can see, is between the radio layer and the potential apps consuming the V2X data. Basically, here the vehicle will create these V2X messages that they get to the radio layer and via different VLANs. And here the VLANs are important because in terms of isolation, of security, will arrive to the Kubernetes side, to these modules, which then via the broker could be distributed to other V2X.com or to the different applications. As we are using VLANs here in Kubernetes, we need multi-CNI. Of course, a CNI is needed in terms of providing connectivity between Kubernetes nodes. Helm chart, Helm is provided to package all the application. And we are using an open source MQTT solution called Mosquito. As I mentioned, the latency is a critical requirement. So here we propose a V2X edge infrastructure. In our proposal, we are considering different layers. We have a cloud layer where, for instance, we could be running open source MANO, an edge layer where we could run the broker, the MQTT broker, and this far edge layer, which would be really close to the final users, to the vehicles, so that the pre-processing of the V2X messages could be done here. So in our use case, and as I will later showcase, we are implementing the roadside units in post lamps, and inside the post lamp, we are also introducing lightweight devices, lightweight computing devices, which are Kubernetes node, and we run these V2X.com pods over there. So yeah, let me show you how we deploy the V2X stack making use of OSM. Here's the general architecture. We have OSM here, a Helm repo, and this would be, as I mentioned, a Kubernetes cluster. And here an important detail is that the V2X.com, as I mentioned, must be placed in the far edge to guarantee low latency. The broker could be placed in the edge or the cloud layer. And an important thing is that the relation for each roadside unit that we are considering in our scenario, in our network topology, we will instantiate a V2X.com, and a different VLAN will isolate the traffic. So this is how we use OSM to instantiate the solution. The good thing is that only with 2 network services, one for the V2X.com and the other one to the broker, we are able to implement the network topology that we are considering. So in our case, as I will show, we consider 2 post lamps. So we instantiate 2 V2X.com with different instantiation parameters. Here we could specify which VLAN, which node in a specific, and for instance, the service name of the MQTT. And we need only one MQTT broker to serve all the solution. And well, with the instantiation parameters, we could specify in which node or in which layer are we willing to instantiate it and which is the service name. And let me show you a video. Okay, so well, This is the solution deployed by OSM. To do so, of course, we need to previously onboard the network services that are formed by BNFs. So if we go to the BNF section, we could see that we are using Helm charts, and we are using a open source Helm chart repository called Chart Museum. I will show it in a second. Here we have it. It's in our infrastructure. Here we are storing our Helm charts. And well, this is the structure of the Helm. Simple structure. We have the deployment and the service that is exposing it. And then regarding the V2XCOM, we have the deployment. And as we need this VLAN requirement, we have a network attachment definition. So OSM is able to, via the instantiation parameters, specify what I mentioned before, in which node, which VLAN, etc. Here we can see how to example of instantiating the solution. Here we have the MQTT. And to instantiate the V2XCOM would be the same procedure. The good thing here is that it's an scalable solution, because if we are introducing a new post lamp, a new road unit in the infrastructure, it's as easy as coming to this menu and instantiating again, specifying the node and the new VLAN. So here we can see that the V2X tag is getting instantiated. Here I'm using Lens, which is a dashboard for Kubernetes. Also, we created a namespace with a resource quota, so we could limit the maximum amount of resources that the pods could use. Here we can see that the solution is up and running. And let me show you a bit about the radio. In this example, we are using 11P, which is this enhanced version of Wi-Fi adapted to vehicles. We need a OCB interface, which is the radio interface interacting with the vehicles. And here we can see the radio configuration, the channel, the bandwidth, etc. And to end, let me show you a connectivity test. We will explain we will show how the data was flowing through all the system. So here's real data transmitted via 11P CAN messages. So again, we could simply run a TCP dump and observe that the packets are received in the radio interface. Here we have the geo-networking protocol. Then let's check the VLAN interface, which is created making use of multi-CNI. So here again, as you know, ETH0 is the default interface. In our case, ETH1 is our secondary interface, which is configured to the VLAN. Here we are receiving the message. Here, as we are using MQTT, we could check that the packets are sent checking the MQTT topic. So we are simply subscribing to the topic of the secondary V2XCOM module, because here the focus is an end-to-end. And the last part, we are checking in the roadside unit in the VLAN interface that the packets are received. And from there, they are transmitted via radio to the other OVUs. So basically, one vehicle is sending messages to the other vehicle, making use of the solution. Okay, and then let me continue with a second demo. This is a quick video where I will show you how we validate this in a real environment, in a real scenario in Barcelona. So here we have a tram stop, then a bike lane, and then some pedestrian area over here. So we noticed that a lot of accidents were being produced because some pedestrians were exiting the tram stop, and as here we have a bike lane. This is a risky situation, so we develop a risk detector application on top of the V2X stack that I show, that basically takes the location of the different OBUs, which in our case is electric scooter, takes care of the location of the tram, and if it detects that there's a risk, it arises such warning. So here we could see the roadside unit. Here again, we have the radio side unit, the 11P antennas. Also, we have a lightweight Kubernetes node here running the V2X COM, an image of the tram, and here is our OBUs, which basically is an electric scooter with this gadget. And let me show you the risk that we are trying to avoid. So here again, the bike lane, the tram lane. So you can see we are approaching, and basically when we arrive to such area and the tram is located close by to the OBU, we will arise a critical LED at the right. We implemented the intermediate warning alarm, and then we can see critical, the red LED. As you can see, is a quite a risk situation. That basically would be the validation. And okay, so some attachments to the projects that where we have been developing such solutions: Caramel project, Pleasure project, and Onofre 3. And some literature supporting the work from what we've been producing regarding the V2X, the security, and the interoperability. And that would be all regarding my side. I don't know if you have any question. I will be happy to answer.
That was an interesting demo. Thank you so much for that. Do we have any questions? It was really cool now.
No questions, I guess that was clear enough.
No, Adrian, I have a question.
Yeah.
It's pretty interesting because I come from this 5G background.
Yeah.
So it's more like we are going in that direction. That the radio connectivity you mentioned, you are all using the open source project for this, right? Or any specific requirement for that?
For what? Sorry, could you come again?
For the radio connectivity, is there any specific requirement, or is
the solution in terms of radio is basically sending, well, it depends, because it depends which radio connectivity are you using. In this case was 11P. So no, I don't know if I get your question.
No, actually you specified actually that you. I think my bad. 1 minute. Can you hear me now?
Yes.
Okay. Basically, the question was that you mentioned that you're probably using a Wi-Fi device from the bicycle, right?
Exactly.
And how it was connected to the radio. Was it on 5G, or you were connected to any Wi-Fi spot at that point of location, and then exchanging all these messages?
Exactly. Well, here the solution could be using different radio technologies. As I mentioned, in this case, this real example was with this 11P, with this enhanced version of Wi-Fi. So basically, you need to onboard some Wi-Fi antennas into the OBU, into the vehicle, and the same antennas into the roadside unit. So it's directly Wi-Fi connectivity between the OBU and the roadside unit, and from there you are in the network fabric. So by fiber you get into the different layers of the edge.
And the cloud itself is, and the cloud on which you deployed it, it's on your domain. It's in your environment. It's in your network, right?
Yes. This case was a private cloud with different layers. But you could use a public cloud. The only thing is that you might take care of the latency, of course, depending on what kind of application are you cooking.
No, of course, that's good. Okay, thanks for the moment.
Welcome.
But it was interesting. Can we get these slides somehow, or?
Yeah, I guess they are available in the ecosystem page.
Yeah.
Oh, okay.
Yeah, let me show you the link.
I'll check that. Thank you very much.